Alright, so here we are with the 3-5 assignment for Algebra 1, Intermediate Algebra, and we are going to go through finding the line of best fit. So this is something we did before our break here, but hopefully we can kind of remember. If you want the calculator, the TI-84 graphing calculator, we can go ahead and go to the overview of Intermediate Algebra, and then we just go here to the TI-84 Plus CE edition. And once we click start, and then this tiny little graphing calculator button, we get an option of graphing calculator. So here's our graphing calculator. First thing that they want us to do in this application is to find the line of best fit. So how do we find the line of best fit? We need to input all of this data. So if you don't remember the exact steps, we do have our video that talked about how to find the line of best fit with the calculator. So that's right here. And then kind of what that means. So again, how to find the line of best fit, you're going to need to first turn your diagnostics on. So we're going to go to this catalog down here. So the second button and then catalog. And then we're going to go all the way down to D for diagnostic. On this calculator, you can actually do it a different way, but this is how I like to do it, I guess. So there's our diagnostic. Notice I press enter, enter, and then it says done. So then we need to input the data into the table. So we're going to go stat, then edit, and talk about our list 1 and list 2. So stat, edit has already been selected, and then we get to input our data here. So we're going to input our data based on this table here. So I'm going to do some screen arranging so that that can happen. Let's see. There we go. So you can, if you're using your computer, type in from your keypad, but the problem is that it usually doesn't keep up with you if you are a fast typer. So you kind of have to pause between each one, but that is much easier than typing, or tapping with my mouse. All right, let's see if I got them all. 27. How many should there be? 8. Okay. Then we move over to the next one. Keeping a look at your data to make sure that it does actually input it as you're typing. All right, so now we can see our lists are both the same in length, and so now we can actually find our line of best fit. So this is what we did here. We did stat, edit, entered the x values into L1, y values into L2, and now we're going to do second quit in accordance with our option here of how to get it done, our notes. Then we need to actually calculate the line of best fit. So we're going to go stat, then we're going to click over calc, and then we're going to go down to linreg. So we're going to go to stat and over to the column for calc, and then down for number 4, which says linreg, and then press enter, and then depending on what which one you're using, you're going to press enter quite a few times. Basically, you're trying to just get down to this word calculate so that you can calculate the line of best fit. So here is our equation. Notice that they give us this equation, and they're telling you that A is 2.7-ish, B is 71.9, and then we've got our R squared and our R. And going back to our notes, that R value, here it is, the closer that it is to 1 or -1, and in this case our R value is 0.99, that's very nice, that means that it's a strong positive correlation. So if I don't want to take the time to actually plot out each of these points, it is going to look something like this, where a line will go through it very nicely. So flipping back to our assignment here, we need to find the line of best fit. So I'm going to write that in by making this screen smaller so that I can see the calculator. There we go. So writing that in, I'm going to write y equals, or f of x equals, because we are doing a function, but either way, y equals an a value of 2.75 And then there's supposed to be an x next to that, and then plus our b value of 71.97. All right, so that's going to be our line of best fit for this data. The correlation coefficient for this data, you do want to put as many pieces of this number as you can, so I'm actually just going to take the time to write the whole thing, because sometimes the correlation is actually so close that you actually need one of these decimal places towards the end here. So let's see if I wrote that down right. 2263. Yeah. All right. So it's our R value. And so what does this R value tell you about the line of best fit? It's a positive correlation, which means it's going to have a positive slope. We'll say and slope. And from that number, it's close to 1. And in fact, I'll add very close to 1. And so because of that, it represents the data very well. Again, writing with my mouse here, so looks like crap. All right. Then, now that we know what's happening here, they're saying, hey, with a humerus of 32 centimeters, what would a woman's height be? So if you didn't take a look, the table here is talking about bone length and height in women. So what happens is if an anthropologist finds a humerus in a burial site or whatever, if they know that it is a female humerus, you can check with the DNA, then you would be able to kind of use this chart. Obviously, this is a basic representation of it in order to find out how tall that person might have been. Of course, lots of factors, but based on this data, this is actually a very close representation of what would happen. So we need to remember that our humerus length is x and our height is y. And so notice that they're saying that the humerus is 32, which means the x is 32. I'll actually put this down here. So if the x is 32, what we're actually trying to find is the function that we've already talked about with a 32 plugged into it instead of an x. So if I take the time to rewrite the equation, and instead of an x, I put 32, we can find out what their height is going to be. So, kind of give myself that idea that the height is going to be my result. If you take 2.75 and multiply by 32, let's see, you're going to get 88. Ooh, what a nice whole number. All right, so 88, and then plus that 71.97. That means that the lady's height is going to be 159.97 centimeters. And of course, that's what they're asking up here. So we can just put that over here. All right. So I was just about to ask if we have questions, but no one is here. Okay, so I mean, my cat's here, but anyway. All right. So with a humerus of 32 centimeters, the woman is going to be 159.97 centimeters, which of course to me does not make sense because I don't do centimeters, but hey. All right. So that is kind of the idea of how to use this line of best fit, how to know how it correlates, and how good of a prediction this 159 height is. We have one more example, so we're going to kind of go through this same thing again. Again, the notes from the video are over here, kind of talking about how you would go through figuring out that line of best fit. So we're going to do this again. So we'll clear out what we have here. The diagnostics are already on this calculator unless I've exited the window, which I haven't. And so I can just go ahead and input my data. So I go over to Calc. Go over to Edit. And then you'll notice that you have each of this data point in here. You can either press delete a bunch of times, which is super fun, or you can press clear and then the arrow down button, and then that actually clears the whole column. So if you have a really long list, that's always nice to know. So the data that we are inputting this time is right here. So we'll go ahead and put in each of these data points. And I'm using my keyboard numbers, so it's very fast. Well, faster. And then the next one is 22. So in order to kind of understand what we have going on here, notice that we are having this input of horsepower. So if we put in the horsepower of a car, we'll be able to predict the gas mileage based on that. So interesting, because of course the more powerful the engine, the more gas it would need to kind of get all of that moving. So let's see, just want to double check that I have all the numbers without any missing digits. So that would alter everything. All right, so we're going to find the line of best fit for this data. And again, the way that we do that is by going to stat over to the calc, which I was trying to do the first time. And so if we do second quit, we come to the home screen, stat over to calc, down to linear regression number 4, and press enter a bunch of times, boop. And now we get a new equation. So our new equation is still a y equals ax plus b, and this time I think I'm going to be smarter and just type it, because duh. So let's see. We're going to do y equals our a value, which is negative 0.14, next to the x plus 47.51. All right, so that is our equation. For the r value, we have negative 0.9161 445,339. So that's our r value. And again, noticing what we have in our notes, if the r value is very close to -1, we have a strong negative correlation. So we'll just take that size typing. So what does this tell you? We have a strong negative correlation and slope. And then what does that mean for this data? The line of best fit fits the data, predicts the data or trend. How about, there it is. So the line of best fit predicts the trend of this horsepower versus gas mileage. All right. So with a mileage of 20 miles per gallon, so again, we kind of want to note which thing is which. So our horsepower is X and our mileage is Y. And so notice that they're saying mileage instead of horsepower. So that means that our Y is going to be equal to 20. So that means that we're actually going to take 20 and set it equal to our equation here. And so how do we solve this? Well, we're going to subtract the 47.51 from both sides of the equal sign. So let's see. Boop. Where is my pasted thing? Here it is. So we're going to subtract that out and subtract it from here, which makes a negative number of negative 27.51. And then the only thing left over here is our 0.14. That is a negative, so just so we know, we're going to divide both sides by negative 0.14. Got some copying and pasting going on here. Probably easier than typing. Which will be nice, because if we divide a negative, like it shows here, by a negative, we are going to get a positive number, which we would want for, there's no negative horsepower in a car. And negative 0.14. So that means that we have 196.5 of our value of horsepower here. I would assume RPMs. All right. Oh, and then this says height because of the last problem, so I'm sorry. There we go. Okay. It's just because I copied and pasted the parts A through D. All right, so that's kind of the idea of how that works. So we've used our calculator to find the equation of the line of best fit. We used the calculator to find out what that meant, or how close it is to representing what we have. This one here, I mean, it says strong, but if you think of this as percentages, this is kind of like 91% effective. So, you know, I mean, to each his own, that's a minus of representation, but that's better than an F, right? So, hey, all right. So that's kind of what we're looking for on that, and that's the end of the assignment.